In today's class, we want to talk about isotopes. Now, what are the areas that we look forward to cover under isotopes? We have the first one. Now, if we are done with these three topics under isotopes, trust me, I don't think there is any question under isotopes that we will not be able to answer. So that's basically, I'm teaching you guys this and its applications, how you can see it in exams, all right? First thing first, what is isotopes? Because we need to really understand isotopes before we proceed into looking at those various subtopics. Isotopes are atoms that have same atomic number but different mass number. There are atoms that have same atomic number but different mass number. Now let's assume this. Please note that atomic number is the same thing as proton number. So when we say proton number, I'm also referring to as atomic number. So let's assume an atom has this symbolic representation. This Z you're seeing here is the atomic number, which is also known as proton number. Whereas this M is mass number. Now, mass number can also be called nucleon number. So anytime you see something like this, Cl1735, this 17 you're seeing here is the atomic number, which is also known as what? The proton number. Whereas this 35 is the what? Mass number. Okay, so since we've actually understood or seen the concept behind this, now let me give us an example of isotopes. Common examples of isotopes that we know or that exist, we have the most common example is chlorine, chlorine 35, chlorine 37. Now two of them, they have the same atomic number but different mass number. And the difference in the mass number is due to the difference in their neutron number. So in case somebody asks you, the difference in mass numbers of isotopes is as a result of the difference in their neutron number. Okay, so another example of this, we have hydrogen, we have this. Now this is proton. This is deuterium, and this is tritium. Right? Now these are the three isotopes of hydrogen. If you notice, they all have something in common. 1, 1, 1. This is the atomic number. We also have carbon, carbon 12. These are the two major ones. Most times you can also have carbon 14, but these are the two major ones. So in other words, isotopes are basically atoms with the same atomic number but different mass number. So one of the ways question can be asked is maybe they can ask you, please don't mix up isotopes, isotopy and allotropy. Now isotopy is a phenomenon, right? In case somebody, isotopy is a phenomenon whereby two atoms with same atomic number exist or have different what? Mass number. But isotopes is basically the examples in question. Atomic particles. Determination of subatomic particles. Subatomic particles. We have the first one, electrons, protons, neutrons. Now, this neutron has no charge. In other words, it is neutral in nature. Now proton is positively charged, while this guy is negatively charged. And I went ahead to tell us that nuclear charge is same thing as protons. Because nucleus, well, we're going to see this shortly. So you can just put this down. These are the subatomic particles that we can see in an atom. Every atom possesses electrons, proton and neutron. So let me show us this. Let's assume this is an atom. Now this is actually seen as shells. This is a nucleus. This nucleus is what is housing proton and what? Neutron. Both proton and neutron resides in the nucleus. Electrons circles around the orbit. Alright? So between these two now, or between these three, the one that determines the weight of the atom is proton and what? Neutron. Okay? So mass number is proton number plus neutron number. Now, what even, imagine in a case whereby you're asked to calculate the number of electrons, the number of protons present in an atom, and they give you an atomic symbol. Now with this formula you can do that. Proton is same thing as atomic number. So say proton number is same thing as atomic number. They will always give you this one. Now electron number, for you to know the number of electrons, is simply going to be proton number minus charge. So take note of all these formulas. So we have examples here to actually check out what we have done. Now, mass number of an atom. Please note that mass number is same thing as what? Atomic mass. Mass number of an atom is same thing as atomic mass. So mass number is always equal to proton number plus the what? Neutron number. Is it not so? Now let's look at this question. They said the mass number of an atom is dash. This option is wrong. This is wrong. I don't want to waste my time. The correct answer is what? E, right? Because mass number is sum. This is sum of proton and what? Neutron. And they say the sum of protons and neutron. They will not always use the number. Proton number is something as protons, right? So the answer to this question is because mass number is sum of this. Now the next one says atomic number is 55, atomic mass is 133, which means this is cesium, has a symbol of CS. Now this place is 55 and this guy is 133. They say the nucleus of cesium therefore contains dash. Do not forget that the nucleus contains the mass number. I told us earlier, right? The proton and the neutron is embedded in the nucleus. Do you understand this question? I repeat, the nucleus of an atom contains the proton number and the what? Neutron number. In other words, the nucleus contains the mass number, right? To solve for the mass number. But the mass number of this guy is made up of what? So I'll come here, I'll say, first, let's find out the number of proton present here. Let's find out the number of neutrons, the number of protons, and the number of what? Electrons. So let's start. I'll say neutron, capital letter N. Neutron is mass number minus what? Proton number, right? Please, somebody with calculator or just use your phone. Now, neutron is mass number minus proton number, which has the symbol of Z. Mass number, which is the same thing as atomic mass, is 133. Proton number is 55. Please, what's the answer there? 78, right? So the neutron is 78. Now, proton number, let's use here to be P. Proton number is 55. This one you don't usually calculate for it. It's always given. Proton number is 55 because this is what is written as the subscript here. So this is 55. And electron, we said, for us to get the number of electrons, we say proton number minus what? This guy is a neutral. There is neither positive nor what? Negative. So here, electron is proton. The proton is 55. There is no charge. That is 0, right? So this is 55. So let's check out the one that is correct. Nucleus of cesium therefore contains, please, nucleus don't usually contain electrons. Nucleus only contains proton and what? Nucleus is what is holding the mass number, right? Mass number is proton and what? So any option that has electron here, you cancel it out. Anyone that has electron can do what? So let's start. There's electron here. I cancel it out. There's electron here. I cancel it out. Between these two now, the answer lies between these two. Neutron is how many? 78. Which of these two has 78 neutron? C. So the correct answer for that sub is what? C. So this guy is wrong. Now, let's look at the next one. An isotope has an atomic number of 17 and a mass number of 36. Which of the following gives the correct number of neutrons and proton? Let's solve for the proton and neutron. Proton is always equals to atomic number, isn't it also? Proton is same thing as atomic number, right? And what is atomic number here? 17. P is 17. Neutron is always mass number minus proton number, right? And they gave us mass number here to be what? 36. And proton number to be what? 17. Please subtract this for me. 19. Alright, so therefore we have 17P and 19N. Which option best describes that? Option C. So that is how these things can be asked. Very simple and very direct. We have a question here. An atom can either be neutral like this, or negatively charged like this, or positively charged like this. Now you need to understand something, that what makes an atom neutral is when the number of electrons is same thing as the number of protons. Electrons are negatively charged, right? Protons are positively charged, you know so? So when both of them are equal in number, they will cancel out each other, right? So anytime you have, for example, if I have 10 proton, 10 electron, that atom will be neutral. Because the proton, which is a positive charge, is same thing as the electron, which is a what? Negative charge. So they will just cancel out. But anytime you have something like 10 proton, positive charge, 9 electron, negative charge, they are not the same. If you subtract 9 from 10, 1 will still remain. So anytime proton is higher than electron, that atom will be positively charged, right? By the number of charge, by the difference in their subtraction. 10 minus 10 is 0, neutral. 10 plus, proton is already greater than electron, so this guy will be positive charged overall, right? If we had 10 electrons and 9 proton, what do you think this guy would be? Is he negatively charged or positively charged? Because electron is greater than proton, is it not so? Do you understand? So since electron is greater, the excess will now make it to be negatively charged, right? So in summary, when the protons and the electrons are the same, are equal in number, that guy is a neutral atom. It's neither having positive nor what? Negative. But when the proton is greater than electrons, that guy becomes positively charged, right? When electron is greater than protons, it becomes what? Negatively charged, right? So having that in mind, let's look at this question. They said, a particle that contains 9 proton. Class, whenever you're talking about charge, I have no business with neutron. Neutron comes in when I'm talking about the mass of the atom, right? But if I'm talking about charge, I have no business with neutrons, right? Protons is 9, electron is what? 10. Class, this guy, will he be positively charged or negatively charged? Negatively charged, because electron is greater than what? Proton, right? Do you understand? Now, they said A, this is wrong. This will not be the answer, right? Neutral atom, this cannot be the answer, right? Neutral atom, this cannot be the answer. But the answer is now what? Because electrons is greater than what? Protons. That's the concept. Now you come down to the next one. They will say a particle that contains 11 protons, I have no business with this guy, right? And 10 electrons. Class, would this guy be positively charged or negatively charged? Positive, because proton is always positive charge, electron is always what? So since this guy is greater than this guy, overall charge will be what? Positive. So this guy will be positively charged. Is it not so? Now, let's look at this. A very neutral, cancel out neutral. First in first, right? We are left with, remember in this case, we do not have positive or negative, right? So remove the neutral first. Now let's deal with this. Metals cannot be negatively charged. Metals are always positively charged. Is it not so? And non-metals are always what? Negatively charged. So since the overall charge of this guy will be what? Positive. Is it not so? Positive charge, is it peculiar to metals or non-metals? Metals. Metals always lose electrons. If they lose electrons, they become positive, right? Non-metals do what? Gain. So the answer to that question is what? Metallic ion, because a metallic ion is always a positively charged ion. Do you understand? A non-metallic ion is always a what? Negatively charged. Now this is the second phase in which question can be asked under isotopes. Now calculation of relative atomic mass. Now I said for two isotopes, relative atomic mass, for you to get the relative atomic mass, you have to take into consideration the mass of the first isotope. This mass is something as mass number. The mass number of the first isotope times its percentage abundance. They always give you the abundance. Abundance can be given in either percentage or just normal abundance. Plus mass of the second isotopes times percentage abundance of the second isotope. You know, so all over 100. I said note, you only say divided by 100 if this abundance is in percentage. If the abundance is not in percentage, right, you will not divide by 100. Let me give you an example. When they say something is in percentage, when you add it up together, it gives you 100, right? That is why you are dividing by 100. There are times whereby they give you the abundance in terms of decimal. We call it fractional abundance. If they give you in fractional abundance, when you add it up, it must give you 1. It will give you what? In that case, you're going to divide by how many? 1. I'm dividing by 100 because when I add up the percentage, it will give me what? 100. Now look at this question. Calculate the relative atomic mass of chlorine having two isotopes. This is the first isotope. Mass number is what? And this is the second isotope. Mass number is 37. With percentage abundance of 75 and 25 respectively. Anytime they use the word respectively, what they are trying to tell us is that the first value matches with the first one. The second one matches with the what? Second. Right? So this is the abundance of this one. And this is the abundance of this. Is it not so? So let's insert this into this formula. So we say RAM is equals to, the mass of the first isotope is 35. So we'll put this 35 times. Abundance of the first isotope is what? 75. So this is 75 plus the mass of the second isotope is 37. Percentage of the second guy is what? 25. Divided by what? 100. If you press your calculator, this will give you this. 35.5 AMU. Most times it can be 35.45. AMU means atomic mass units. Take note of that. Now this is basically elementary part of this. Now let's look at how the question can be twisted. Please look up. Now let's look at this question. This is very similar to what we did previously, right? An element Z contains 90% of this. Now this is the percentage abundance of this first isotope, right? And this of this. So in other words, the mass of the first isotope is 16. The percentage of the first one is 90. The mass of the second one is what? And percentage is what? 10. This is relative atomic mass equals to, the mass of the first one is 16 times 90, right? Plus mass of the second guy times the abundance, is it not so? 18 times what? 10 all over what? 100. Please, you can press your calculator and get your answer. Anyhow. Now, let's look at this guy. This is a very technical question. This time around, they gave us the mass of the first isotope, 20, right? They gave us the mass of the what? Second one. But they did not give us percentage abundance. Instead, they gave us in ratio, right? So you don't have to worry yourself. It means that this one is for the first one, and this one is for the what? Second one. Let's take it like that, right? Now let me give you an example. Anytime you have ratio, if they say 1:3, if to make it very simple, take it to percentage. Take it to what? Percentage. Now, for me to know the amount this one is contributing, the total, anytime you have ratio, the total is always 1 plus 3, which is equal to what? 4. That is a total. Out of these 4, they splitted it. Let's say 2 persons are to share 4, right? One will take 1, the other person will take what? 3. So percentage of this one, we say percentage of the first one, right, will be, okay, let's do it like this so that I will just solve it at once. I'll say first isotope equals to x20, right? Second isotope equals to x what? 22. What we do not know is the abundance, right? But they told us is in a ratio of what? 1:3. So this is what you're going to do. I'll say x20, x22. 1 is to what? 3. Right? Now let's find the percentage of this one. For this one, I'll say 1 divided by the total of the ratio, which is how many? 4 times what? 100. And in this case, now I'll say 3 divided by the total, which is also what? 4 times what? Now this is 25. This is 75%. And this is 25%. We can now come here and say I'll say relative atomic mass equals to the mass of the first isotope is what? 20 times what is the abundance of the first one? Right? Plus the mass of the second guy is what? 22 times what? All over what? Now 21.5. So which option is that? Option C. Please, let's talk about abundance. Now, if you remember this formula I just gave us, now, for us to solve this, we need to know the mass of the isotope. Is it not so? They will give us the mass of the isotopes, right? They also gave us the abundance. Is it not so? They gave us the mass of the second, and they also gave us what? Now, in some cases, they will ask you to solve for this abundance itself. Do you understand? But this time around, they will give you the relative atomic mass. Because if this abundance is given to you, they will ask you to solve for relative atomic mass. Right? If they give you relative atomic mass, they will ask you to solve for what? The abundance. So it's more like a vice versa, right? Class, we have a question here. They said, this is the formula. A chlorine consists of 2 isotopes. 35, Cl, 35, and Cl, 37. Is it not so? Now, in the ratio of 3:1, this is 3, and this is 1, right? Now, they now said, calculate the relative abundance of mass number what? Which is this one, right? You don't really have to go through this long process. Remember what I told us earlier, that anytime they give you something like this, you can convert it in percentage, right? That's just what they're asking you to do. Just convert this to percentage. Total percentage is always equal to what? 100. But this ratio, you say total ratio equals to 1 plus what? 3 equals to what? 4. Out of these 4, 35 is contributing 3, is it not so? 37 is contributing how many? 1. So for me to find the percentage contributed by this one, right? I'll now say 1 divided by what? 4, which is the total, is it not so? Times what? 100. That is what? 25%. And what is the answer here?